Welcome back, dear students. So in the today's class I will solve miscellaneous exercise of the chapter 2. Okay, so all the problems of this miscellaneous exercise are very important. They will ask questions from this also. Okay, so see the questions. So find the value of the following. Okay, in that first one, cos inverse of cos 13 pi by 6. Okay, in that see first check the angle 13 pi divided by 6. So what is the value of 13 pi divided by 6? So it is equal to the 390 degree. Okay, so this doesn't belongs to the range of the cos function. Okay, cos inverse function, that is 0, 5. That's why first we have to reduce this. Okay, so our question is cos inverse of cos 13 pi divided by 6. Okay, now this is equal to, keep cos inverse and cos as it is. Now changes we have to make in this angle, that is, see 13 pi is there. Okay, for that pi by 6 multiple of 6 is 2 pi. Okay, for that 2 pi plus pi by 6. See here, 6 into 2 pi is 12 pi. 12 pi plus pi is 13 pi. Okay, so again we will get a 13 pi by 6, same as it is, and this is in the first quadrant. Okay, 360 plus theta, cos 360 plus theta is cos theta only. Again all are positive in the first quadrant. Okay, so now it will become cos inverse of cos 360 plus theta is cos theta. Okay, so this is equal to cos inverse and cos get cancels, remaining is pi by 6. So pi by 6 is 30 degree. This belongs to the range of the cos, that is 0, 5. So value of this function is 5 divided by 6. Okay, next second one, tan inverse of tan 7 pi by 6. Okay, so first check for the value of this angle. Okay, like this. So no need to write this in your exam also. Okay, just understanding purpose this one. Now 7 pi by 6 value is, okay, 7 pi by 6 value is 210 degree. Okay, so see this doesn't belongs to the range of tan, that is minus pi by 2 to the pi by 2. That's why so we have to make changes in this, concentrating the quadrants. Okay, tan inverse of tan 7 pi divided by 6. Okay, this is equal to, keep tan inverse tan as it is. Okay, changes in this are, see 7 pi is there, 6 plus 1 will be 7. Okay, pi by 6, pi plus pi by 6 we will get, see pi plus pi divided by 6. This is the third quadrant, 180 plus theta. So in the third quadrant tan is positive as per ASTC rule. Okay, so this 6 LCM 6 pi plus pi is 7 pi, 7 pi divided by 6 again. Okay, tan inverse tan 180 plus theta is tan theta. Okay, this is equal to the pi by 6. Okay, this belongs to the range minus pi by 2 to the pi by 2, right? Okay. See the next question. Prove that 2 sin inverse 3 by 5 is equal to the tan inverse 24 by 7. Okay, so we have to convert this sin to the tan. Okay, for that I will use one standard formula. Okay, first write down the given 2 sin inverse 3 by 5 is equal to the tan inverse, means we have to prove this one. Okay, given this we have to prove. Okay, take LHS from this. LHS is 2 sin inverse of 3 by 5. Okay, so sin to the, first we have to convert this 2 sin to the sine. Okay, that for that use 2 sin inverse x is equal to the sin inverse of 2x into square root of 1 minus x square. Okay, this is the formula I will use here now. Okay, so 2 sine inverse x means 3 by 5, sine inverse of 2 into 3 by 5 root of 1 minus 3 by 5 square. Okay, this is equal to the sine inverse of 6 by 5. Okay, root 9 by 25 is equal to the sine inverse of 6 by 5. 25 minus 9 is 16. Okay, root of 16 divided by 25 is equal to the sine inverse of 6 divided by 5 into root 16 is 4 by 5, 4 divided by 5. This is equal to the sine inverse of 24 divided by 25, right? So what we need? Tan inverse. Okay, for that convert this to the angle. So I will made here calculations. Sine inverse of 24 divided by 25 is equal to theta. I will write. Okay, sine theta equal to 24 divided by 25. Okay, so right angle triangle theta, sine theta opposite by hypotenuse 24 25. So one more triplet is here, we will get a 7. Okay, for that now I will define tan theta in this. Tan theta opposite by adjacent side 24 divided by 7. Okay, theta equal to tan inverse of 24 by 7. See here, this is theta. Okay, theta sine inverse of 24 by 25 equal to tan inverse of 24 by 7. This is equal to tan inverse of 24 divided by 7 is equal to the RHS. Okay, so only extra thing I used here is this formula. Okay, right. Next one, fourth one, sine inverse of 8 by 17 plus sine inverse of 3 by 5 is equal to the tan inverse of 77 divided by 36. We have to prove. Okay, so I have to prove this sine inverse plus sine inverse equal to tan inverse. I have to prove. Okay, so for that first write down the LHS in the solution section. LHS, sine inverse of 8 by 17 plus sine inverse of 3 by 5. Okay, so just convert these two to the tan. So I will draw the triangle here. Theta, sine is opposite by hypotenuse always. Okay, so 8 divided by 8 opposite the hypotenuse, 8 17. So what is the one more triplet of this? That is 15. Okay, so then define in this tan is equal to the tan inverse. Tan is opposite divided by adjacent, 8 by 15, 8 by 15. So this is sine inverse of 8 by 17 equal to tan inverse of 8 divided by 15 plus for this. Okay, this is a theta again, 3 by 5 opposite divided by hypotenuse. One more triplet is 5. Now defining this tan inverse of opposite by adjacent, 3 divided by 4, 3 divided by 4. Okay, so this is equal to the tan inverse of 8 divided by 15 plus 3 divided by 4 divided by 1 minus 8 divided by 15 into 3 divided by 4. Tan inverse of x plus tan inverse of y formula, tan inverse of x plus y divided by 1 minus xy. Tan inverse of 15 into 4, LCM is 60. Okay, so 8 into 4, 32, 15 into 3, 45. Okay, so this is equal to the, next is divided by, so here also LCM is 60. 60 minus 8 into 3, 24. Okay, tan inverse 32, 45. Okay, this is equal to the 77 divided by 60 minus 24 is 36. Okay, so see, the result, required result is 77 divided by 36. This is equal to the tan inverse 77 divided by 36 is equal to the RHS. Very simple way. So convert this sine to the tan and this sine to the tan. Just draw a right angle triangle and put these values. Write the one more triplet. So you know how to write the triplet. Okay, so for this also write one more triangle, write the triplets and write the tan inverse. Like sin theta cos theta, how you will write now? In the same way, sin inverse and tan inverse also you should write. Nothing difference in that. Okay, nothing will change, you will get the same value. Okay, the next question, fifth one, cos inverse plus cos inverse equal to cos inverse. This is a very important problem, already asked 2-3 times in the annual examination. Okay, we have to show that cos inverse plus cos inverse equal to cos inverse only. So there are 3 methods to solve this question. Okay, one is using a trigonometry formula. Okay, and one more is using inverse trigonometry formula, and one more is using right angle triangle. Okay, so I will write one way here, simplest way, using the inverse trigonometry formula. Okay, so write LHS first. Cos inverse 4 by 5 plus cos inverse of 12 by 13. Okay, so we know that cos inverse of x plus cos inverse of y is equal to the cos inverse of xy minus square root of 1 minus x square into square root of 1 minus y square. Okay, this is the formula to convert cos plus cos to the cos. Cos inverse plus cos inverse is equal to the cos inverse conversion formula. Okay, so use this formula. Cos inverse of x plus cos inverse of y is equal to the cos inverse of x into y, x by 4 divided by 5 into 12 divided by 13 minus square root of 1 minus 4 by 5, x square means this, into square root of 1 minus 12 by 13 square, right? This is equal to the cos inverse of 4 into 12. Okay, so this is 48, 5 into 13, 65. Okay, 65 minus square root of 1 minus 4 square is 16 divided by 25 into square root of 1 minus 12 square is 144, 13 square is 169. Okay, close the bracket, is equal to the cos inverse 48 divided by 65 minus square root of 25 minus 16, that is 9 divided by 25 into square root of 169 minus 144. So this is 25 divided by 169 is equal to the cos inverse of 48 divided by 65 minus, so this is 3 by 5 into 5 divided by 13. Okay, 169 root 169 is 13 is equal to the cos inverse of 48 divided by 65, right, minus 15 divided by 65 is equal to the cos inverse of LCM is 65, 48 minus 15 is 33 divided by 65. So this is equal to the RHS. Required result is cos inverse of 33 divided by 65. This is the using the standard formula cos inverse plus cos inverse y. So there are two methods still, using one trigonometry formula, that is cos x plus y formula, and using the trigonometry angles, that convert this cos to the tan, this cos to the tan inverse plus tan inverse of phi formula apply. So we will get a tan inverse result. Again convert that tan inverse to the cos inverse using the right angle triangle, using the triplets. Okay, very important problem this one. For 3 marks they will ask, for 3 marks. Okay, next one is 6th one, cos inverse of 12 divided by 13 plus sin inverse of 3 divided by 5 is equal to the sin inverse of 56 divided by 65. 56 divided by 65. Okay, so see here dear students, this is of cos plus sin is equal to the sin. So we know sin plus sin equal to sin formula, sin inverse of x plus sin inverse of y formula. So for that reason I will convert this to the sin. Okay, so write LHS cos inverse 12 divided by 13 plus sin inverse 3 divided by 5. Okay, so draw right angle triangle, theta sin cos adjacent divided by hypotenuse 12 13. Okay, so remaining triplet for this is 5. Okay, so then we can write sin inverse in this, sin is opposite by hypotenuse. Okay, 5 divided by 13, 5 divided by 13. Okay, instead of cos inverse 12 by 13 we can write sin inverse of 5 divided by 13. So this is equal to the sin inverse of 5 divided by 13 plus sin inverse of 2 by 5. Okay, for this use the formula sin inverse of x plus sin inverse of y is equal to the, so the formula is sin inverse of x plus sin inverse of y is equal to the sin inverse of x into square root of 1 minus y square plus y into square root of 1 minus x square. Okay, this formula I will use now, is equal to the sin inverse of x plus sin inverse of y. Sin inverse of x 5 divided by 13 square root of 1 minus y square, y is 2 by 5, 2 by 5 square. Okay, plus y is 2 by 5 square root of 1 minus x, x is what, 5 by 13, 5 divided by 13 square. Okay, complete this. This is equal to the sin inverse of 5 divided by 13 into 2 is 4 by 25, 25 minus 4 divided by 25 plus 2 by 5. So square of 13 square is 169, 169 minus 5 square is 25 divided by 169. Okay, this is equal to the sin inverse of 5 divided by 13 into 25 minus 4. Okay, see, 1 second. 3 by 5. Sorry, this is 3 by 5. This is 3 by 5. 3 by 5. 3 is 9. Okay, this is 3 divided by 5. Then this is also 3 divided by 5. 25 minus 9 is 16. Root 16 is 4 divided by 5. 4 divided by 5 plus 3 divided by 5. 169 minus 25 is 144. Root 144 is 12 divided by 13. 12 divided by 13. So this is equal to the, see, sine inverse of 5 into 4 is 20. 13 into 5 is 65 plus 3 into 12 is 36 divided by 65. This is equal to the sine inverse of 20 plus 36 is 56. LCM is 65. So this is equal to the RHS. Right? Very simple one. For 3 marks. They will ask this question also for 3 marks. Use the formula, standard formula. Okay. Tan inverse of 63 divided by 16 is equal to the sine inverse of pi by 13 plus cos inverse of 3 by 5. Okay, all 3 are there in this. First convert these to the a single one ratio. So I will take in this RHS. RHS is equal to the sine inverse of 5 divided by 13 plus cos inverse of 3 divided by 5. Okay, so convert these two to the tan. I will write here theta, this 5 by 13, opposite divided by hypotenuse, this is tall. So one more ratio is tall. Next, so means it will become, using this tan inverse, using this angle tan inverse is opposite divided by adjacent, pi divided by tall. So that is 5 divided by 12 plus, for this I'll draw one more right angle triangle. Okay, theta 3 by 5 adjacent divided by hypotenuse. One more triplet is 4. Okay, so for this tan inverse of opposite divided by adjacent, 4 by 3. Tan inverse of 4 by 3. Sine inverse is equal to this. Cos inverse is equal to the this. Okay, so then now tan inverse of x plus tan inverse of y formula. Tan inverse of x plus tan inverse of y, x plus y, 1 minus x into y is equal to the tan inverse of, see, 12 into 3 is 36 is the LCM, 3 into 5 15, 12 into 4 48 divided by, so again 36 is the LCM. Okay, 36 minus 5 into 4 is 20 is equal to the tan inverse of 15 plus 48 is, see, that is 63. These two get cancelled. 36 minus 20 is 16. Okay, see, required result is 63 by 16 tan inverse, right? This is equal to the ELHS. Okay, very simple way. Just use the right angle triangle and triplet concept. Okay, if you know the triplets very well, you can solve it very easily. Okay, next question is 8th one, important one. Tan inverse of 1 by 5 plus tan inverse of 1 by 7 plus tan inverse of 1 by 3 plus tan inverse of 1 by 8 is equal to the pi divided by 4. Okay, I have to show that this is equal to the pi divided by 4. See, take LHS. There are 4 functions in this So make two groups, group of 2 first, next 2. Okay, tan inverse of 1 by 5, tan inverse of 1 by 7. Okay, one group plus tan inverse of 1 by 3 plus tan inverse of 1 by 8. So next one more group. For these two, apply tan inverse of x plus tan inverse of y formula. Okay, so is equal to the tan inverse of x plus y, 1 by 5 plus 1 by 7 divided by 1 minus 1 by 5 into 1 by 7. Okay, plus tan inverse of 1 by 3 plus 1 by 8 divided by 1 minus 1 by 3 into 1 by 8. Okay, so this is equal to the tan inverse of LCM is 35, 7 plus 5 divided by 35. This is equal to the 35 minus 1 divided by 35. 5 into 7 is 35, 35 minus 1, 35 minus 1 divided by 35. These two will get cancelled. Okay, tan inverse of, here is the LCM, 3 into 8 is 24. Okay, so 8 plus 3, cross multiplication, 24 divided by this 24 minus 1 divided by 24, 24 get cancels. Okay, so remaining is tan inverse of 7 plus 5 is 12 divided by 34, 12 divided by 34, so it will get cancelled. 6 ones are 6, 17s. Okay, next, sorry, 2 6s are 2 17s are. Okay, tan inverse of this is 11 divided by 23. Okay, so now use the formula tan inverse of x plus y again, that is equal to the tan inverse of x is 6 by 17, 6 by 17 plus y is 11 divided by 23 whole divided by 1 minus 6 by 17 into 11 divided by 23 is equal to the tan inverse of C. So what is this? 17 into 23 is 17 into 23, LCM become 391. Okay, that is 391. 6 into 23 is 138 plus 17 into 11 is 187. Okay, so now down. So here also 391 is the LCM, 391 minus 6 into 11 is 66. Okay, is equal to the tan inverse of 138 plus 187 is 325. 391 minus 66 is 325. Okay, so 325 get cancels, is equal to the tan inverse of 1. So tan inverse of 1 is equal to the pi divided by 4. So proved pi by 4 is equal to the RHS. Okay, see here dear students, we have to apply the tan inverse of x plus tan inverse of y formula 3 times in this question. First for these two, next for these two, again in this step. Okay, so very simple calculations. Okay, you can solve it very easily. Very important question for 3 marks. Okay, right. See the next question. Tan inverse of root x is equal to 1 by 2 cos inverse of 1 minus x upon 1 plus x when x belongs to the closed interval 0 comma 1. Okay, solution is so consider LHS. Tan inverse of root x, right? This is equal to the, I will multiply and divide it 2 tan inverse root x. Okay, so we know the formula tan inverse in terms of cos, that is 2 tan inverse of x is equal to the cos inverse of 1 minus x square divided by 1 plus x square. Okay, so I will use this formula for this. 1 by 2 as it is. Okay, 2 tan inverse root x, this is x, cos inverse of 1 minus root x square divided by 1 plus root x square, right? This is equal to 1 by 2 cos inverse of root and square get cancels, root and get cancels, remaining 1 minus x divided by 1 plus x. So this is required result. Okay, RHS. Okay, now so next question, 10th one, cot inverse of root 1 plus sin x, root 1 plus sin x plus root 1 minus sin x, okay, divided by root 1 plus sin x minus root 1 minus sin x is equal to the x divided by 2. Okay, x belongs to the 0 comma pi divided by 4. Okay, so in this we have to solve for this is equal to, we have to solve simplest form we have to take. Okay, so question is cot inverse root 1 plus sin x plus root 1 minus sin x upon root 1 plus sin x minus root 1 minus sin x. Okay, so in this case we have to prove this is equal to x by 2. In this case, so consider LHS solution, LHS 1 plus sin x 1 minus sin x upon square root of 1 plus sin x minus square root of 1 minus sin x. Okay, so I will rationalize this one first. Okay, so how to rationalize? Multiply and divide, okay, the term opposite to the denominator. Okay, so this is equal to the LHS is equal to the cot inverse of okay, okay, this is cot inverse of root 1 plus sin x root 1 plus sin x plus root 1 minus sin x, okay, root 1 plus sin x minus root 1 minus sin x into, okay, into root opposite to this means plus root 1 plus sin x plus root 1 minus sin x. So same thing we have to divide 1 plus sin x plus root 1 minus sin x. Complete the bracket. Okay, rationalization I am doing is equal to the cot inverse of C, this x plus y into x plus y, so it will be x plus y whole square. Okay, root 1 plus sin x plus root 1 minus sin x bracket square upon C a minus b a plus b. So this is a square minus b square form, that is 1 plus sin x square minus 1 minus sin x square. Okay, so this is equal to the cot inverse of, see, a square plus b square minus plus 2ab I will write. So 1 plus sin x square, okay, plus root 1 minus sin x square plus 2 times root 1 plus sin x root 1 minus sin x, okay, divided by square and square get cancelled, square and square get cancelled, 1 plus sin x, 1 plus sin x minus 1 minus into minus plus sin x plus sin x, okay. So here also in the numerator square and square get cancelled, square and square get cancelled, cot inverse of 1 plus sin x plus 1 minus sin x plus 2 times square root. So I will write these two in single square root, 1 plus sin x into 1 minus sin x, 1 plus sin x into 1 minus sin x, okay, upon, see, 1 get cancels, sin x plus sin x is 2 sin x, sin x plus sin x is 2 sin x, okay. So here sin x get cancels, so remaining is cot inverse of 1 plus 1 2 plus 2 root a plus b, a minus b, so again a square minus b square, it will become 1 minus sin square x divided by 2 sin x divided by 2 sin x is equal to the, so take 2 common and cancel this denominator term, that will be cot inverse of 1 plus 1, so 1 minus sin square is cos square into square root will get cancelled, remaining is cos x divided by sin x. So already I cancelled 2, taking a 2 common from these 2 to get cancelled, so remaining 1 plus 1 into, so 1 minus sin square is cos square and square root get cancelled, remaining is cos x, 1 plus cos x divided by sin x, okay. So is equal to the, see, cot inverse of 1 plus cos x can be written as 2 cos square x upon 2 divided by sin x can be written as 2 sin x upon 2 cos x upon 2, half angle formulas, okay, 2 cancels, 1 cos cancels, cot inverse of cos by sin, cot x upon 2, so cot and cot inverse get cancelled, so is equal to the x upon 2, so where x belongs to the closed interval 0 comma open interval 0 comma 5 by 4, okay. So this is our very simple, just do carefully, okay, rationalize this and concentrate on this calculation, practice well, you will get it, okay. Question number 11, prove that tan inverse of root 1 plus x minus root 1 minus x upon root 1 plus x plus root 1 minus x is equal to the pi by 4 minus 1 by 2 cos inverse of x. So x is less than or equal to the, greater than or equal to the minus 1 by 2, less than or equal to the 1, okay. So for this we can go through the substitution method, okay. So what we have to substitute means, so we need cos on the RHS and that is 1 by 2, okay. For that substitute x equal to cos 2 theta, okay. Now see here, put x equal to the cos 2 theta, this implies 2 theta is equal to the cos inverse of x, and theta is equal to the 1 by 2 cos inverse of x, right? 1 by 2 cos inverse of x. So 1 by 2 cos inverse of x, that's why put x equal to cos 2 theta. Consider LHS. LHS is equal to the tan inverse of 1 plus x minus root 1 minus x upon root 1 plus x plus root 1 minus x. Okay, so substitution, tan inverse of root 1 plus x is 1 plus cos 2 theta minus root 1 minus cos 2 theta, okay, divided by root 1 plus cos 2 theta plus root 1 minus cos 2 theta. Okay, this is equal to the tan inverse of, see, 1 plus cos 2 theta is 2 cos square theta, okay, under the root 2 cos square theta minus 1 minus cos 2 theta is 2 sin square theta, okay, upon 1 plus cos 2 theta is root of 2 cos square theta plus root of 2 sin square theta. Okay, so this is tan inverse of root 2 separate and square root get cancelled, root 2 into cos theta minus root 2 into sin theta divided by root 2 into cos theta plus root 2 into sin theta. Okay, so now take a common root 2 in the numerator and denominator, cancel each other. So this is equal to the tan inverse of remaining is cos theta minus sin theta divided by cos theta plus sin theta plus sin theta. Now divide numerator and denominator by cos theta. Okay, divide numerator and denominator by cos theta, cos theta. So that is equal to the tan inverse of cos theta minus sin theta upon cos theta. Okay, so all divided by cos theta plus sin theta upon cos theta, okay, is equal to the tan inverse of cos theta is 1, sin by cos is tan theta divided by cos is 1 plus sin by cos is tan theta. Okay, so this is equal to tan inverse of, I will write 1 as a tan pi by 4, tan pi by 4 is 1 minus tan theta upon tan pi by 4 plus tan theta. Okay, so this is tan x plus minus tan y upon, once again sorry, 1 plus, I will write here tan pi by 4, okay, into tan theta. So tan pi by 4 is 1 into tan theta is again tan theta, no change in the value of the previous step. Okay, so tan x minus tan y divided by 1 plus tan x tan y, this is tan x minus y formula, tan inverse of tan pi by 4 minus tan inverse of tan theta, okay, equal to the tan inverse tan get cancelled, remaining 5 by 4 minus tan inverse tan get cancelled, theta, this is equal to the pi by 4 minus theta is 1 by 2 cos inverse of x, 1 by 2 cos inverse of x. So where x is less than, x is greater than minus 1 by root 2 and less than or equal to 1. So this is the required result, RHS. Okay, so see next question, one more, question number 12. Question number 12, 9 pi by 8 minus 9 by 4 into sin inverse of 1 by 3 is equal to 9 by 4 sin inverse of 2 root 2 divided by 3. Okay, we have to prove this very important problem. Okay, so consider LHS. LHS is 9 pi by 8 minus 9 by 4 sin inverse of 1 by 3. Okay, is equal to the, see, take 9 by 4 common, 9 by 4 remaining is pi by 2, pi by 2 minus sin inverse of 1 upon 3, sin inverse of 1 upon 3 is equal to the 9 by 4. See, pi by 2 minus sin inverse is cos inverse, that is cos inverse of 1 by 3 using the formula. So sin inverse of x plus cos inverse of x is equal to the pi by 2. So I need cos inverse of x. Cos inverse of x equal to the pi by 2 minus sin inverse x. Pi by 2 minus sin inverse x. Okay, so now, so 9 by 4 is okay. We need sin inverse. Convert this cos to sin. Okay, put in the right angle triangle, theta. So adjacent divided by hypotenuse, 1 3. Okay, this is ex. Okay, so 3 square is equal to the 1 square plus x square. This is 9 minus 1 square is 1. I will take this side, x square. So x square equal to the 8. This implies x equal to the plus or minus 2 root 2. You will get 2 root 2 will get. So x equal to the 2 root 2. Okay, so 9 by 4 sin inverse of opposite divided by hypotenuse. Opposite is 2 root 2 divided by 3. Okay, so this is equal to the RHS. Very important problem for 3 marks. They will ask this question for 3 marks. Question number 13. Solve the following equations. 2 tan inverse of cos x is equal to the tan inverse of 2 cosec x. Okay, so this is for 2 tan inverse x. Okay, so for this I will write tan inverse of 2x, that is cos x, divided by 1 divided by 1 minus x square. X is cos square, that is 1 minus x square. So formula 2 tan inverse of x formula. Tan inverse of 2x divided by 1 minus x square is equal to the tan inverse of 2 cosec x. Okay, so cancel tan inverse and tan. 2 cos x upon 1 minus cos square is sin square x, sin square x. So this is equal to 2 cosec x. So that we can write as a 2 divided by sin x. Cosec x is equal to 1 by sin x. We can write 2 get cancels. Okay, 1 sin get cancels. Cos by sin is cot x is equal to the 1. X equal to the cot inverse of 1. So x is equal to cot inverse of 1 is pi divided by 4. So value of x in this equation is x equal to the pi divided by 4. Okay, next is 14th one. Okay, 14th one, tan inverse of 1 minus x divided by 1 plus x is equal to 1 by 2 tan inverse x, x greater than or equal to the greater than 0, sorry, greater than 0. Okay, we have to solve for x in this. So see the solution. Okay, tan inverse, take 2 to this side, 2 tan inverse 1 minus x divided by 1 plus x is equal to tan inverse x. So again tan inverse x formula, that is, so tan inverse of 2x divided by 1 minus x square, same formula we have to use here. Okay, tan inverse of 1 minus x divided by 1 plus x divided by 1 minus x divided by 1 plus x square is equal to the tan inverse of x. Okay, so cancel these two, tan inverse and tan inverse, remaining is 2 into 1 minus x upon 1 plus x, okay, divided by 1 minus x square, 1 plus x square, 1 plus x square will become LCM 1 plus x square, it will multiply to this side 1 plus x square minus 1 minus x square is equal to the ex, remaining is x. So see here 1 plus x, 1 plus x will get cancelled, so this remaining 1 plus x will come in the numerator. Okay, 2 1 minus x 1 plus x upon remaining is 1 plus x square, 1 minus x square. Okay, a plus b whole square, a minus b whole square, this is 1 square plus x square plus 2x minus a minus b whole square, 1 square plus x square minus 2x is equal to the x. Okay, 2 into 1 minus x square upon, okay, 1 plus x square plus 2x minus 1 minus x square minus into minus plus 2x is equal to the x. So see here 1 get cancels, x square get cancelled, remaining 2x plus 2x is 4x. Okay, 4x, sorry, 1 minus x square divided by 4x equal to the x. So 2 1s are 2 2s are, and take this 2x to this side. Okay, multiply to this. So this is equal to the 1 minus x square equal to the x into 2x is 2x square. Okay, so take this side, 1 is equal to 3x square, 2x square minus x square will become plus x square, it is 3x square. Okay, x square is equal to the 1 upon 3, so x equal to the plus or minus root 1 by 3, x equal to the plus or minus 1 upon root 3, 1 upon root 3. So value of x in this is, important question is x equal to plus or minus 1 upon root 3. Next is 15th question, question number 15. Okay, so that is sin tan inverse of x mod x less than 1 is equal to the options A x upon root 1 minus x square, b 1 divided by root 1 minus x square, c 1 divided by root 1 plus x square, option D x divided by root 1 plus x square, root 1 plus x square. Okay, so see the solution for this. Okay, the formula for this, so tan inverse in terms of sin inverse, that is tan inverse of x equal to the sin inverse of x divided by square root of 1 plus x square is the formula. Okay, I will use this here, that is sin of, in the place of tan inverse I will put this sin inverse x divided by square root of 1 plus x square. Okay, so sin inverse get cancelled, remaining is x upon root 1 plus x square. So option is D, right option is D. Using the conversion of tan inverse to the sin inverse formula, we can write it very easily. Okay, question number 16, sin inverse of 1 minus x is x minus 2 sin inverse of x equal to pi by 2. Okay, we have to solve this. Given up 4 options, we have to take the right one. Okay, sine inverse of 1 minus x minus 2 sine inverse of x is equal to the pi by 2. I will take this sine to the this side. Okay, so this I will take. Okay, minus 2 sine inverse in this place only, pi by 2 minus sine inverse of 1 minus x. Okay, we know the formula, sine inverse of x plus cos inverse of x equal to 5 by 2. So on the basis of that, pi by 2 minus sine inverse is cos inverse 1 minus x, that is minus 2 sine inverse x. Okay, take cos to this side, cos inverse will become cos minus 2 sine inverse of x 1 minus x. Okay, cos of minus 2 theta is cos theta is equal to 1 minus x. Okay, cos 2 theta can be written as cos 2 theta is equal to the 1 minus 2 sine square theta. Okay, so here see cos 2 theta, this is our theta, remember this is our theta, so that's why 1 minus 2 sine square we have to write. Okay, sine square theta, so theta is sine inverse of x is equal to 1 minus x. Okay, so 1 minus 2 sine inverse of x bracket square is 1 minus x. So sine inverse and sine get cancels, x remains, x whole square is square, 1 minus 2x square is equal to 1 minus x. Okay, right, so 1 get cancels, minus 2x square equal to minus x. Okay, right, minus 2x square, take this side, minus 2x square minus x equal to plus, it will become plus x square. So 2x square minus x equal to 0 is the equation. Okay, so from that I will solve here. Okay, take x common, 2x minus 1 is equal to the 0, x equal to the 0 or 2x minus 1 equal to the 0, x is equal to the 1 by 2. Okay, so here x is equal to the 1 by 2 does not satisfy the equation, that's why, so answer is x equal to the 0. So x is equal to the 0, option C is right one, x equal to 1 by 2 does not satisfy the equation. Okay, see the next question, 17th one, this is also of multiple choice type. Okay, so first solve, then tick the right one, tan inverse of x by y minus tan inverse of x minus y divided by x plus y. Okay, in the second one, in the second tan inverse, so divide numerator and denominator by y. Okay, tan inverse x by y minus tan inverse x minus y upon y divided by x plus y upon y. Okay, is equal to the tan inverse of x by y. Okay, minus tan inverse of x by y by y is 1, x by y minus 1, this is also x by y plus 1. Okay, this we can write as a tan inverse of x by y minus tan inverse of x minus y divided by 1 plus x into y. Okay, so this is tan inverse of x by y minus tan inverse of 1. Okay, tan inverse of x minus y formula, tan inverse of x minus tan inverse of y is equal to the tan inverse of x by y minus tan inverse of x by y, minus into minus plus tan inverse of 1. Okay, this cancels, remaining tan inverse of 1. Tan inverse of 1 is pi divided by 4. Okay, so right option is C is the right option. Okay, so dear students, this completes your inverse trigonometric entire chapter, including miscellaneous examples and miscellaneous exercise. I solved all the problems without leaving any single problem. I solved all the problems, very important problems for the examination. They will ask compulsory, all the questions from the inverse trigonometry chapters are very important. Okay, practice well. If you have any doubt, you can contact us. Okay, thank you.